In this video, I introduce a pseudo-labeling method for semi-supervised learning. Consider a multi-layer neural network with m layers of hidden units as shown here, and explained in this figure, this layer key and this layer key minus 1, this weights and this bias. Where S key is a nonlinear activation function of the layer key. For example, sigmoid function S expressed in this formulation and rectifier activation function as expressed in this formulation. The network is trained by minimizing supervised loss function as shown here, where C is the number of the labels and N is number of samples, where yi is a true label, fi is the predicted probability of the positive class. Using the sigmoid output unit, the cross-entropy loss L is defined as here, which penalizes both positive and negative predictions as shown here. When prediction is same as the true label, the model penalizes the negative prediction, otherwise penalizes the positive prediction. Denoising autoencoder is unsupervised learning algorithm for autoencoder training based on the idea of making the learned representations robust to partial corruption of the input pattern. DAE can be stacked to initialize a deep neural network as shown here, where XG tilde is a corrupted version of the input value XG. XG caret is a reconstruction of input value XG. The autoencoder training minimizes the reconstruction error between XG and XG caret. For example, corruption can be additive isotropic Gaussian noise, as shown here, where epsilon sampled from a normal distribution. For binary input value, a common choice of the reconstruction error of cross-entropy is this formulation. DAE is an unsupervised learning method. DAE is now applied to semi-supervised learning through dropout, in which hidden units is randomly masked with the probability 0.5 as shown here. Traditionally, a deep neural network trained with semi-supervised learning consists of two phases. First, pre-trained with unlabeled data in unsupervised fashion, and then fine-tuned with labeled data in supervised fashion. Pseudo-labeling is a semi-supervised learning method which trains a network in a supervised fashion with labeled and unlabeled data simultaneously. Pseudo-labels are target classes for unlabeled data as if they are true labels. The class is picked with the maximum predicted probability for each unlabeled sample as shown here. The pseudo-label is used in fine-tuning phase with dropout. The pre-trained network is trained in a supervised fashion with labeled and unlabeled data simultaneously with the overall loss function as shown here. This for labeled data and this for unlabeled data. Where alpha is an important scaling factor. If alpha is too high, it disturbs the training even for labeled data. Whereas if alpha is too small, we cannot get benefit from the unlabeled data. For more details, please check with these references. Thank you. Bye.